let's go over the Module 4, Project 1. We're going to go through a little bit of the prompt, the template, and how to do some of this stuff in Excel. So the main idea this week is that we are sticking with the real estate data. I know you guys are probably super excited to keep going with the real estate data. The scenario is you've been hired by a DM-PAN national real estate company to develop a model to predict median housing prices for homes sold in 2019. The CEO of DM-PAN wants to use this information to help their real estate agents better determine the use of square footage as a benchmark for listing prices on homes. Your task is to provide a report predicting the mean housing prices based on square footage. To complete this task, use the provided real estate data for the U.S. home sales as well as the national descriptive statistics and graphs provided. I want to take a step back before we dive into the details. One thing that I think gets a little confused here is how these models are used. So let's step back. We have this sample data from 2019. We are using that to develop a model. We are then going to use that model to make predictions going forward. So let's say that I have this model I developed, right? We have some model where we have B0 plus B1 times X, right? So now let's say I have a real estate agent that has a 2,000 square foot home that he wants to list next week. So then you would run that through the model. You would find out what the Y hat is, the predicted amount, and that would give you an idea of the listing price. I've seen a lot of reports in the past that talk about, well, this is silly, square footage isn't the only thing that matters with housing price. No, it's not. In reality, you would use probably what we call multiple linear regression, where we would use many variables, or you would use this as some kind of a benchmark and then kind of go from there based on neighborhood or number of bedrooms or age of house. There are other indicators. This is just to give you an idea of how a practical use for linear regression. So keep that in mind when you think about how to use this model and what we're really doing. All right, let's look at the directions. Using the Project 1 template located in the What to Submit section, generate a report including your tables and graphs to determine if the square footage of a house is a good indicator for what the listing price should be. Reference the National Statistics and Graphs document for national comparisons and the Real Estate Counties data spreadsheet, both found in the supporting materials section for your statistical analysis. Note, present your data in a clearly labeled table and use clearly labeled graphs. That's another mistake that's commonly made. People don't label charts or graph titles or columns for when we report the summary statistics. So it's really important to label so that the reader knows what you're reading. Specifically include the following report. Now we'll go through this in a little bit more detail as we talk about the report. I want to share, I've gone ahead and downloaded the template. So this is what the template looks like. It's very similar to our other templates. One thing I want to point out, anything in square brackets should be deleted prior to submitting. A lot of people leave in some of the brackets or change the order. Listen, stick with the order, put information where it's supposed to go. One, the reason for this is it's kind of trying to get you a good idea on how to structure your reports in a business environment or professional environment. But two, when I'm grading, it's really hard to find the required elements if they've been moved all around. Now, having said that, I do want to caution you, there is a small difference between this template and the prompt, and that's in the process of getting fixed. But for now, I just want to point it out. Here in your introduction, in the template, it just says describe the report. Here in the prompt, it gives you some more specific things to include, like your question your report is trying to answer, explain when using linear regression is most appropriate, etc. Now, if you go down here to data analysis, some of that information is saying it here in the template. So what I would recommend you do is try to include all that up here in the introduction. You need to keep the structure here, like introduction, data collection, etc. But the prompt is how the rubric, the grading rubric is set up. So make sure you're looking at the prompt to include all the required information. All right. And if you're ever unsure too, you can also go all the way down here and see the rubric, and it'll give you the different sections so you at least know what order things are supposed to go in. But again, this prompt lines up with the rubric, so I would follow the prompt. All right. So let's go ahead and dive in. So the introduction, as I just mentioned, this is stuff that you do need to put into your own words. However, we'll touch on it a little bit. So define the question your report is trying to answer. Well, we're trying to predict listing price with square footage. Is that possible? Is that something we can do with linear regression? Those are kind of what we're looking at. Explain when using linear regression is most appropriate. In other words, when using linear regression, what would you expect the scatter plot to look like? So there's a couple things. When we use linear regression, we expect that there's correlation between the variables. But I also want to point out here, this is from Zybook section 2.1. Here's an example of something where linear regression might be appropriate. It's negative, but it's still linear correlation. Here's an example of a nonlinear trend. So there's still a trend in the data, but it's more curved. You might also find where it's scattered all over the place crazy, and that's might not be appropriate. So talk about what you expect the scatter plot to look like, and then explain the difference between the response and the predictor variables in a linear regression to justify the selection of variables. And we've touched on this in previous sections, or previous modules, excuse me, but one thing to remember is we use the predictor variable. That's our input. Would it make sense to predict square footage with the listing price? Would we care about that? To talk about the business justification for why we would want to predict the listing price using square footage. All right, data collection. So we're going to talk a little bit more in Excel. So sampling the data, select a random sample of 50 counties. It does not say select a region. You should not be selecting a region. This is from the overall national data set. Then again, you need to identify your response and predictor variables here. So before we talked about the definition, but here we just need to identify. So here's our Excel spreadsheet. So for those of you that haven't done the random sample before, all of you should have, but I know some people are having a hard time. We're going to create that random variable equals RAND, open close parenthesis, and we are just going to copy that all the way down. Now, some of you also remember that what I recommend doing is selecting this, hit Control C, Command C, which depends on what type of computer you're on, come over here, and we're going to copy special, or excuse me, paste special. The reason for this, let's say you make a mistake somewhere, but not in the whole report, and you just want to go back to your sample and you don't save it the same way that I do, you want to be able to reference those same 50 counties again. And that's just good, I call it good housekeeping in my Excel sheets. So we're going to click paste values, because if you'll notice, so now what that did is that pasted all the values from that random number generator. But every time you hit enter now on your spreadsheet or do anything like K, it'll regenerate these random numbers. So that's why we did that special. So we're just going to go ahead and delete this column. And then what we're going to do is copy this. Oops, did not mean to do that. Scroll all the way down. And we're going to copy. Oops, I am not doing a very good job of this. All right, copy. And then we're going to paste it over here. Just to keep good housekeeping. Delete that. All right. And we don't care about that source thing up here. Okay. So now what we're going to do is select our entire data set. Again, we're not selecting a region. Select the entire data set. We're going to sort, custom sort. We have the header. Since I selected that one, we're going to do it by random, smallest to largest. It doesn't matter. You could do largest to smallest also. Oops, looks like it did not do it. Did I click the wrong button? Oops, let's get that last one in there. Not that it matters. Sort, custom sort. I'm going to select on random. Click, there we go. Okay, so now what we're going to do, I copy my header also. So we started on 5. Remember, we need 50. So that means we need to go down to the 56th row. So we're going to copy this down to 56. Right there. We're going to hit Control C. And what I do is I always create another tab, bring it on over. So now we have our nice data set of 50. Okay, so now we would just need to explain that in our template over here. So we would have written our introduction already, our sampling data. We would just explain how we use the random function and then sorted. All right, now we need to come up with a scatter plot. Let's go double check our prompt and see what it says. Create a scatter plot of your response and predictor variables to ensure they are appropriate for developing a linear model. So at this point, we're not actually looking at the trend line. We're not looking at the regression equation. We're not looking at R squared. We are just looking to see the pattern of the data and see if it's appropriate for developing a linear model. So what we talked about in the intro is what we expect that scatter plot to look like. Let's check and see if it does. So first what we're going to do, this is a weird quirk. You have to put your X variable in front of your Y variable or else it'll get all messed up and then it's a pain to fix. So I've shown in a previous video how to fix it, but let's not mess with that if we don't have to. So we're going to go ahead and put square feet. We're going to cut this and we're going to put it over here in front of listing price. I'm going to just delete that column. So now we have median square feet in front of median listing price. This is our X and this is our Y. So we're going to highlight all the way down. And we're going to come up here to insert. So here you have your list of plots. And we'll see later that our histogram is here and our scatter plot is here. So we're going to bring this up here. Oops, if I didn't drag that in the wrong spot by accident. Here we go. All right, one other thing to pay attention to, are your X and Y correct? I do see sometimes that students mix it up where you have square footage here and you have listing price here. That's a problem. If you see that, then you need to switch it or start over, okay? So right now I'm looking at this, there does seem to be an overall positive linear trend here. I don't see a ton of obvious outliers. These might be an issue, but they're in that linear pattern that I'm not too concerned about them at this point. I don't see a curved pattern. So I would say at this point it's pretty linear, but I do want to point out something. You need to label these things. So here we're going to put, you could either put scatter plot, you could put square footage versus listing price. You could put a lot of different titles there. You just need to make sure that whoever is reading this knows what you're talking about. One thing I also recommend doing is adding chart title, or excuse me, axes titles. So for the vertical, we have, listing price, and we're going to add in a horizontal. Again, this is all over here under the drop down for add chart elements. We're going to add horizontal. And this is square footage. And I want to make a note. I know this is the median square footage for the counties. I'm just putting in square footage and listing price because I think, especially in this class, it can get very confusing to talk about the mean median square footage. So I'm just putting square footage and listing price. All right, so that's our scatter plot. Let's see what it says over here on our prompt. Here we have, okay, and I would put in a little blurb saying, yeah, we see an overall linear pattern, and this looks like so far it's appropriate for linear regression. Okay, so next is we're going to do histograms for our two variables. So there's a couple ways to do this. It depends on what you have available in your version of Excel. First, though, I'm going to tell you right now, I'm going to copy this and I'm going to paste it over in another tab just because we're going to run out of room to see everything. So let's delete that. Okay. So to do your histograms, you're going to go to insert, and there's two ways to do this. This is your drop down for histograms. I will caution you, I had an outdated version of Excel and it did not have that option. I updated Excel and it showed up in there. So if you don't see that, I recommend updating Excel and giving it a shot. If you don't, the other way is to go to data and go to data analysis and use the histogram option here. So those are two viable options. Let's go ahead and go just to this option within the menu. So we're going to click histogram, and it helps if I actually highlighted the variable. So we're going to start with median square feet. And I'm going to show you two ways. This way I did not highlight the label. So we go to insert. So I've already highlighted the data. Histogram. See, it pops up with it. It didn't put any title in there. So I'm going to write square footage. Again, it's very important to label because without that, you have to go look down here at the scale. Now, it's obvious to me, but it's really important, especially in a business environment, to properly label your work. So the next one we're going to do is median listing price. We're going to go to insert, histogram. And see, notice on that one, I did include the chart title or the header, and it didn't do anything. It recognized it as non-numeric and it ignored it. Okay, I just wanted to show you guys what happens in either case. So here we're going to go ahead and type it as listing price. And there's your two histograms. Pretty simple, right? So we're going to copy and paste these over here as well, because it makes life a little easier for viewing, especially as we keep producing more and more. Put these next to each other so we can see them easily. And just delete these out of here. All right, let's go back to our prompt and see what else we need to do. So we did our histograms, and then we need to do our summary statistics. For your two variables, create a table to show the mean, median, and standard deviation. Now, I've seen a lot of versions of tables, and honestly, a lot of them are very difficult to read. I recommend keeping it as simple as possible. So we're going to do mean, median, standard, if I can type, deviation, and then we're going to have square footage and listing price. Again, simple table, right? So remember, for mean, we do equals average, and we highlight that column. If it scrolls down for me, there we go. Now it went a little too far, so see, I'm going to backspace and hit 2. So we know it's D2 to D52. We're going to close parentheses, click enter, and that gave us our mean. Now we're going to do the median, and since we know it is D2 to D52, we're going to hit enter, and then we're going to do standard stdev.s, because remember, this is our sample, and again, it's D2 to D52. Click enter. There we go. Now we're going to do our listing price equals average. Now we know it's E2 to E52. You can either highlight it or type it, whatever is easiest for you. And close parenthesis. I find it easier just to type it or copy it. So equals median E2, E52, equals std ev.s, open E2, E52. All right, there's our nice little table. I highly recommend grid lines. I have found several that I could barely tell which column went with which when you copy it over to Excel. Now, I will say this, copying this over, I have issues. I'm on a MacBook, which obviously is not like super in love with the Microsoft Office products. So I have a problem just copying and pasting this. I often have to screenshot it to copy and paste it. So I hit Shift Command 4 and just go like this. I'm not too picky if that extra little gray grid line shows up in there. And then you end up with this nice little screenshot that you can just copy and paste into your report. Is it the prettiest? No. The other option is even just going into your Word document. Where would this go? This goes under summary statistics here. So I'm not deleting everything, but you can insert table. Where's our table? And do, what was it? 3 by 2? 3 by 2? No, 3 by 3. And you can just type all these. Oops, I think we needed one more actually. You can just insert another one. Well, you can insert another one there. Here, we'll just delete that and insert another one to make life a little easier. Insert table. So we needed a 4 by 3. There we go. So you can type mean, median, standard, deviation, and then square footage. You can just do it like that too. Whatever is easiest for you. But honestly, it shouldn't be any more complicated than this because you want to keep it simple for whoever's reviewing it. Anything else could be a little bit harder to read. I've seen people use like different colors. The only time you want to use different colors if you're trying to specifically highlight something. For example, let's say we had an outlier way out here. I might make that red. Or if I had something that I wasn't expecting, I might make it red so that when I wrote about it in my report, somebody could easily find it referenced. But for the most part, keeping the colors pretty simple is a smart idea. All right, so we've done the summary. Interpret the graphs and statistics. So based on your graph and sample statistics, interpret the center, spread, shape, and any unusual characteristics, and then compare and contrast to the national numbers. So here's your national numbers. The basic idea is we're trying to look, are they normal, symmetrical? Is it right skewed, left skewed? Is your samples like median square footage or mean or median, or like the center, way higher or way lower than the national numbers? it should be pretty close because it's a random sample, but you might find that you ended up with an outlier that greatly skewed your number. So that's definitely something you should talk about there. As far as the shape spread on your own, just look at these. Say, okay, well, this is kind of normal, but it's also kind of less skewed because we have a tail over here. So if you're not sure, go ahead and compare your mean and median, or just say it's not clear from the histogram and explain why it's not. This one's definitely less skewed, which means that we have probably slightly bigger homes than average, but this might be an outlier. See, we have one over here that's very small down here, these two. So they might be worth looking into further. That's just something to point out. You don't have to do anything about it at this point. But just make sure you talk about the shape, spread, and everything in these histograms. Talk about any outliers you see in the scatter plot. Do you see a linear pattern here? Is linear regression appropriate in this case? And compare. Do you have way more expensive, way less expensive, or way bigger or way smaller homes than the national numbers? That's what we're looking for here. Let's go back to the prompt. All right. So now we have... develop your regression model. So we have to do another scatter plot. And this one, we need to include the trend line. Now, we're going to include a little bit more in the trend line. Let's go over here. We're going to create a new scatter plot. Again, we're going to go ahead and highlight those two variables, our X and Y. Remember, X has to be in front. Go to Insert, Scatter Plot. Now, I will tell you, there's another option. I'm going to go ahead and click on this and leave it here. You could just come over here and add in chart elements. You don't have to create a whole new scatter plot. The only reason I sometimes would create a whole new one is like, let's say again, you made a small mistake in your report and you want to go back to it. It's nice to have the different versions of your scatter plots. It's not at all necessary. I'm going to go ahead and do it just because it's helpful to walk through that again anyway. All right, so we created our new scatter plot over here. And again, you would add in your labels. I'm not doing it now just because I'm sure this video is boring most of you at this point. But again, add in your chart title, add in your x-axis and y-axis labels. Now, while we have our chart selected, see the little squares around it that are highlighted. We're going to go to Add Chart Element. We're going to go down to Trend Line. We're going to go ahead and select Linear Trend Line. All right, see how it puts our nice little line there? And it kind of keeps it around our range of values. We're going to add in some more elements. We're going to go down and go to Trend Line, more Trend Line options. I'm going to scroll down and we're going to see Display Equation on Chart and Display R squared on chart. That gives us our coefficient of determination and our linear regression equation. That is not required in this step. I personally find it very helpful. So I'm going to go ahead and put that over here under the other scatter plot. Good housekeeping. Okay, so now we see we do have kind of an overall trend line. We do have a couple values out here, especially this one that might be skewing our results, but it's not horrible. I would, in my professional opinion, we would definitely investigate that further and see if it was worth removing that outlier or if that represented a separate performing population that we might want to segment off and build a separate model. So that would be definitely room for extra investigation. Let's go back to our prompt and see what it says. So we did our scatter plot. So interpret regression equation, interpret this, I'm sorry, I've skipped sections. Discuss association. So based on the scatter plot, discuss association, direction, strength, form in the context of your model. Now, this is something I see a lot of students talk about here. They go ahead and start talking about R. At this point, we're literally just talking about this. Let's pretend like we didn't include this because it wasn't part of our requirements. Just this. We want to talk about how is our data around the trend line. Do we still see a positive, strong, linear pattern now that we've got our line on here? Yes or no? This one's looks maybe moderate at best. I would say moderate, just eyeballing. Again, I still feel like these might be something worth investigating. Let's see what else it says. And it's positive. Remember, it's as X increases, Y also increases. So identify any possible outliers or influential points and discuss their effect on the correlation. So the idea is if you have outliers, they're going to reduce the correlation because they are not like if they're true outliers and not just like, that data is kind of a pain. If they're true outliers, they do reduce your correlation, especially your correlation coefficient, because they're going to be farther from the trend line, or they're enough to move the trend line away from other data where it could be more fitted. So discuss keeping or removing outliers and what impact your decision would have on your model. I want to tell you right now, if you want, you can remove, if you have, like I did another iteration of this where I had an outlier, similar data, but I had a data point like up here in the millions. It's not even on this chart. It was over 1 million, but it was a very small home. And would have been way up here on this chart. I would remove that and move forward because it's greatly skewing your results. And anything you say after that's going to be completely almost useless in a report. So that's up to you. If you're not comfortable removing it, that's fine. Just say, if it were up to me, you would remove it. It would have higher correlation. Whatever the impact would be, go ahead and talk about it there. All right. Find R. Now, there's a couple ways to do this. So you can just pull it from here, take the square root of that R squared. I want to remind you, R squared is always positive. R squared is a measure of distance. R squared is always positive. You might have a negative R and a positive R squared. So the way to know is if you just take the square root of that R squared, your R is always going to have the same sign as your slope. If R is negative, your slope is negative. If your slope is positive, R is positive. So that's how you do. Here we have a positive slope, so we would take the square root of that R squared. Here, I'll just even do it here. Equals square root. What do we have? 0.2793. That gives me 0.52. That's moderate, so that's kind of in what we were talking about. So that right there would give you your R, or you can actually run the regression at this point. So the other option, and I'll show you how to do that, would be to go ahead and go to insert, or excuse me, data. Data analysis. Now, back in module 2, I believe, I posted that video about the difference between equals, that LINEST, linest or linest. You can use that here if you did not install the data analysis pack. If you have any questions about how to do that, go back to that announcement because I went through that in detail, or let me know if you have any questions. For now, we're going to stick with this data analysis tool pack. So click regression, click OK. So our input Y range is, we have E, right? So let's start here, E. It's going to be 2 through 52. And then our input X range is D2, right? That's that square footage column. We do want to output that right here. So we've got our result. I think that's everything for now. Click OK. So that gives us our nice little results here where we have R. So that gives us our R also, or excuse me, that gives us our R squared. Multiple R right there. That's our R. So let's go back. And that gives us, so that gives you R, and that gives your regression equation also. So here we have our intercept and slope. Again, we saw all that over here on our scatter plot. So we would need to put this into, type that into your Word document here. So under linear regression, where are we? The regression equation, we would do Y, well, you would do Y hat. That's, you can type that in, equals, what did we have? Our coefficient, let's say 165.72, 165.72x minus, our intercept is negative 46302, 46302. Go and put 2 decimal places, and that's 24. So that would be, you have to type it in. Some people I noticed leave it in the scatter plot and don't type it here. Make sure you type it here. It is on the rubric. It will get graded. Make sure you type it here. So then it talks about interpreting the regression equation. Right here it says, let's see, interpret the slope and intercept in context. Okay, remember the slope tells us, if it's positive, for every additional square foot, it gives us the increase in listing price. If it's negative, it gives us the decrease in listing price. You need to put that not just in terms, but actually use your number, use your slope. So in this example, I would say for every increase in square footage, the listing price, the listing price would go up 165.72. Okay, that's important. The intercept, remember, that's when x equals 0. And we've talked about that in previous assignments. When x equals 0, that's a land-only sale. So if you have x equals 0 in your sample, that intercept will make sense. However, in this case, we don't have anything at 0, nothing even close to 0. So our intercept is negative, and that doesn't make any sense. Land is not going to equal a negative dollar amount, and just put that. That's what it doesn't make any sense to interpret in this situation. All right. So strength of the equation. So we talked earlier about R. R is the correlation coefficient. That tells us how correlated two variables are. R squared tells us the strength of the equation. That's a measure of the equation, not the variable's correlation, the strength of the equation. R and R squared are obviously related, but these are two different statistics. So R squared, remember, tells us if you multiply it by 100. So in this case, our R squared is 0.2739. So for this linear regression, R squared tells us the percentage of the sample data that's close to the line. That does not tell us in the future how likely we are to get on that line, to get the right, because we don't know what data is going to come through the door in the future. This is just telling us an evaluation of this sample data and this line. So in this case, we would say 27.39% is close to the line. It also tells us the variance in the Y variable that's explained by the X variable. So you could also say 27.39% of the variance in listing price is explained by the square footage. So make sure you understand the difference between R and R squared. Use regression equation to make predictions. So again, you need to plug in a number. So here we have our regression equation. So here you need to actually plug in a number and make a prediction and see what comes out. You could use the square footage of the home you live in now. You could use anything that you think. One thing I do want to caution you though, make sure that the number you use is within the range of values in your sample. You can't, in this case, I couldn't use 4,000 because it's not appropriate to use that model on this data for sure. Use something in the range of values there. All right, and then summarize your findings. So in one paragraph, summarize your findings in clear and concise plain language. I wouldn't just talk about the comparison to the national to the sample. That's not necessarily important. We want to talk more about the regression. We say we found that linear regression was appropriate. This equation will work, something along those lines. When you're giving this report to someone, what would they care about? So just say this was a good representative sample, and we found that linear regression was appropriate or not appropriate, or you found that these outliers were the biggest issue and it could be appropriate had we removed these outliers. What changes could support your results? Again, the biggest one's probably outliers. What other changes could you see? Maybe like looking at stratifying the sample around something along those lines. Provide at least one question that would be interesting to follow up on research. There's lots of options here. That's something you'll have to decide. But yeah, there's lots of options for this stuff. So that's project 1 for module 4. So if you have any questions about like the prompt or how to do stuff, let me know. All right.